Now another application of quadratic equations, and that is with work. You probably have done some problems using work situations before, and so I'll remind you again of the things that we need to do. But let's look at the problem that we have at hand. We have a problem where we have two, and the situation is that Jim can complete a job alone in 1 hour less than his brother Jake. Together they can complete the job in 4 hours. How long does the job take each brother working alone? If you remember that with work situations, what we've done before is we've made a table, and so first of all we've got two brothers, Jim and Jake, and so we're going to write the information that we need in several columns. In the first job. In the second column, we're going to put the rate at which they do the job in 1 unit of time. In this case, we're talking about the last column is going to be the part of the job which is done. Part of job done in so many hours, and we'll talk about that in a few minutes. So Jim give us a situation that what if they were both working together? Okay, so let's now write the information here. It says Jim can do the job in 1 hour less than his brother Jake. So the variation with these problems to the ones that you may have had earlier is that we're comparing Jim's time to Jake's time. Anytime we compare to something else, let's start out with a variable being representing that to which we're comparing. So let's say Jake takes X hours to do the job. Jim can do it in 1 Jake, Jim's time is going to be X minus 1. They can both complete the job in 4 hours, so that's easy to put here. If you remember that the rate at which they do the job in 1 hour, for example, if they were both working together for 4 hours, in 1 hour they would do 1/4 of the job, right? By remembering that, then it's easy to know what to do over here, because if Jake works X hours, in 1 hour he will do 1 over X part of the job, whereas Jim, if he works X minus 1 hour, in 1 hour he will do 1 over X minus 1 part of the job. But now they're both working for 4 hours. That means Jim, in 4 hours, he will do 4 over X minus 1 part of the job. Jake will do 4 over X part of the job. Together, they both complete 1 job. Okay? So we'll say the part done by Jim all of this is going to be 1 job done. Okay? So we said Jim does 4 over X minus 1 parts of the job. Jake does 4 over X parts of the job. Together they do 1 job. And there we have an equation. Now, it's an equation which is an equation involving rational expressions. To solve such an equation, because it has denominators, remember that we're going to be using the lowest common denominator and eliminating denominators. So the lowest common denominator in this case, since we don't have anything to factor, is just going to be the X minus 1 times X. We're going to use X times X minus 1 then to multiply the left-hand side, and we'll do the same thing for the right-hand side. So that's just a little bit of review of what you did in an earlier chapter. When we do that, the left that each of those terms is going to be denominator. X times X minus 1 times 4 over X minus 1 plus X times X minus 1 hand side, but on the right hand side we simply had a 1, so that's just X times X minus 1. So here we have an equation We'll get rid of the denominators. For the first term, the x minus 1's cancel off, and we end up with 4x. For the second term, the x's cancel off, and we end up with 4 times x minus 1. On the right-hand side, we'll multiply that out, and we have x squared minus x. And we've got a quadratic equation. So let's simplify each side. Squared minus x. And let's put everything on the right-hand side. Since it's easy to work with a coefficient which is positive on the x squared. So we'll say x squared. We've got an 8x here by x side. We will have minus 8x minus 1x would be minus 9x, and then a plus 4. So this is equal to 0. Once again, the factors, if they were factorable, they don't jump at me, and so I will go ahead and use the quadratic equation. So a, the coefficient of the x squared is 1, b, the coefficient of the x term is negative 9, and c, the constant is 4. So in the quadratic formula then, minus a, and take the opportunity to learn the quadratic formula. Each time that you have to use it, rewrite it so that it sticks in your memory a little bit better. So the solutions for x are x equals itself is minus, it becomes minus a minus 9, plus or minus the square root of b squared, put that in parentheses, minus 4 times a times 2 times a. All right. So then we go back and simplify. X equals 9 plus or minus the square root of 81 minus 16 divided by 2. And we're going to have x equals 9 plus or minus the square root. Minus 1 is 6. 9 plus or minus the square root of 65 divided by 2. Working with the calculator, I ended up with x being approximately 8.5 hours, or x being approximately 0.46 hours. Now, what you need to do is to go back to the problem and see if the answers make any sense. Do the answers make any sense? Will make any sense. Now x, remember, is the time that it takes Jake to do the job. Okay, so 8 could take Jake 8 hours to do the job, and then Jim 7 hours to do the job. So that answer makes sense. Another way of putting that is that answer is reasonable. What about the x equal 0.46 hours to do the job? Jake isn't going to be able to do the job in half an hour. So throw that answer. It's not a reasonable answer. And so in this case, x is 8.5 hours. That means that Jake will do the job in 8.5 hours. Jim will do it in 7 hours, 7.5 hours.